Hello, and welcome to the first Triangle Computer Science Distinguished Lecture Series. First, I'd like to thank our sponsors at the Army Research Office and our partner departments at Duke and UNC. I'm very pleased today to welcome Richard Ladner, who has had a distinguished career in theoretical computer science and algorithms. However, today he's going to be talking about accessible computing, which is a more recent passion of his, and he's worked very hard at it, been a missionary, and has won several awards, including the Nico Halberman Award and a presidential award whose name I don't exactly remember in detail. But anyway, in fact, that award kind of became the seed for his current work. So anyway, his talk is New Directions in Accessible Computing.
Thank you, Matt. That was a very nice introduction. So, as Matt said, I started out in theoretical computer science, and in the mid-1980s, I got interested in accessibility, but I didn't carry that out very far. And then in the early 2000s, like 2003, 2004, I got interested again, and then it suddenly took me over. So, I always like to start these. I like to start these talks with just some friends of mine who are very successful persons with disabilities in computing. Some won't be in computing, and actually some of them are not my friends. So, but these two are. T.V. Raman from Google is quite an inventor in his own right, and dissertation, I don't know, 15 years ago, he's done one project after another, and he's working on making the Google phone accessible to blind people. And Chieko Asakawa is from IBM Japan. She runs a group of, I don't know, about 15 engineers and scientists, an accessibility group in Japan. I think it's the largest industrial accessibility group in the world. They're both totally blind. And a couple of friends of mine, Raja Halangar, I can't pronounce his last name. I always call him just Raja. So he's deaf, and he's studying for his PhD at the University of. Christian Golger received his PhD at Penn several years ago. And in that picture there, you see a picture of him in front of and behind a signal, which is a signal from those gloves. So his dissertation and some of his work past his dissertation was on trying to automatically understand sign language with people wearing gloves. So interpreting those signals looks pretty difficult. It's one of those problems that's not been solved yet. So if you're interested in an open problem, that's one. I don't recommend it, by the way. It's way too hard. There's a recent person I met, another Indian, Bapin. I'll just call him Bapin, not try to pronounce his name. He's from the Helen Keller National Center. And it's definitely worth reading his biography on the web. He's deaf and blind. And I met him a few weeks ago at a deaf-blind retreat in the Seattle area where there were about 100 other deaf-blind people. And so he's very much a technologist. He doesn't have a PhD yet, but he's trying to get into it. And then this gentleman I do not know, Jonathan Kunaholm. This is a picture of him on the cover of the IEEE Spectrum from, I don't know, maybe a year ago. And he has a missing arm from his battle days, and he's wearing on that arm a new prosthetic that he was part of the development of. So I thought that was kind of interesting that this was highlighted on the major magazine of IEEE Spectrum. In fact, when I'm a member of IEEE, when I received the Spectrum, I got that. It was like, It was just before a talk I was going to give, so I had to slam it right in the talk. And there's another gentleman I've met is a very well-known evolutionary biologist, Gerard Vermeil, and he's totally blind, and he studies shells. And shells are very tactile, so that turns out to be pretty good for him. And he's a distinguished professor at the University of California at Davis. Oh, gosh. This is a picture of Stephen Hawking, who is a very famous physicist. And I don't know him either, but he did visit Seattle a while back, but I didn't get a chance to meet him. And here's a couple of students of mine. On the lower left is Sung-Young Han, and on the right is Zach Ladner. Zach was a math major, and I worked with him several years ago. He's since graduated, and he's out doing some adventure right now. And Sung-Young Han is very close to finishing his PhD at the University of Washington in natural language processing. And they're both totally blind. So I've had a lot of inspirational people that have helped me along the way. And both Zach and Sung-Young have worked on some of my projects, although neither of them is really particularly focusing their research on accessibility, and neither is Stephen Hawking. But you can see that, that people with disabilities can do almost anything in almost any scientific field. And people with disabilities are often highly motivated to pursue careers in accessible computing. So there's a lot of people I know. I know a blind chemist. He's very interested in chemistry, but he also does some accessible making, helps make chemistry accessible. So just sort of a natural thing to do. So today, I'm going to cover some models of disability that you may have not seen. And it does influence my work, so I think it's important to see. A little data. I have a lot more data, but I crossed out all those slides. I didn't want to bore you with all that. And if you want to talk to me about data, you can talk to me after the lecture. Or feel free to ask me any questions during the lecture as well. Also, the impact of accessibility technology generally has had a huge impact, and some of it you know and some of it you don't know. And a little accessibility research, I have to admit I'm going to focus on the work at the University of Washington. There was so much of it that I didn't get into a wide generalization, but I think it just exemplifies some of the concepts that I'm trying to pass over today to you. And one of the concepts I'm going to stress is empowerment and what that means. And then at the very end, if there's time, I will talk about this access computing project and encourage people here at the North Carolina State University to actually get more involved in this access computing project, which is a national project. So first, models of disability. I used to have like 3 of them, and now I have 5. So the first model, and this is the way you think about disability. The first model is called a medical model. It's disabled people are patients who need treatment and or cure. So that's one model. Another model is educational model. Disabled youth need special education. I put that in quotes because it means many different things to many different people. The rehabilitation model, disabled people need assistive technology and training for employment in everyday life. The legal model, disabled people are citizens and have rights and responsibilities like other citizens. Accessibility to public buildings and spaces, voting, television, telephone are some of those rights. So disabled people, simply because of their disability, have certain rights. And there are laws like the ADA, Public Law 94-142, and so on, which spell out some of those legal rights. And most states have lots of laws concerning persons with disabilities. And finally, the social model, which is the model I grew up in, actually, because I didn't know about these other models, is disabled people are part of the diversity of life, not necessarily in need of treatment or cure. They do need access when possible. So the social model really includes the legal model, and to some degree the rehabilitation model, and not very much the medical model. And not very much necessarily the education model. The education model is basically about children, but almost all children grow up and become adults, and then special education doesn't really apply to them anymore. So it's only for children. So the reason I grew up in the social model is that my parents were deaf, and so I sort of learned about disability. I didn't even know that word existed, actually. And so I learned about disability from my parents, and so that's shaped a lot of my attitudes and research. So let's talk a little bit about technology, and I've categorized technology into sort of three categories. Prosthesis, which is some kind of augmentation to restore lost function called a cure. So, maybe that prosthetic arm that works almost like a human arm would be a prosthesis. I think these glasses I'm wearing are prosthesis. They restore my vision so I can see as normal, almost normal. Assistive technology is popular in the rehabilitation literature, which goes back much further than accessible computing goes. So the emphasis there is on need for assistance, that somehow technology will assist you because you are disabled. So there is a bit of this paternalistic feeling that persons with disability are lacking and they need assistance. Actually, if you think about almost all technology, they're assistive technology. Automobile is assistive technology. It helps you get from point A to point B quickly. An airplane I took here is assistive technology and so on. So I'm not sure that any technology is not already assistive technology. So access technology allows for an activity that would be difficult to impossible to achieve without it. So it's not trying to duplicate biology. Emphasis is not on restoring function, but on achieving an end goal by whatever means possible. So a good example is a screen reader for a blind person, which actually allows the blind person to navigate what's on the computer and have it read what's on the screen to them. So they're using their ears and their fingers, so to speak, to substitute for their lack of vision. So it's not trying to give them vision by replacing their retina or whatever is wrong with their eyes, but actually giving them access to do something that they couldn't do without the screen reader. So the screen reader is one of these transformational technologies that has really made a difference for blind people. A video phone is another transformational technology. A video phone is a phone where, actually, you probably used one yourself and use Skype with the not just voice Skype, but video Skype. Doesn't work very well, but it's okay. But there are custom video phones that are for deaf people so that they can talk to each other in their native language, sign language. And I've seen over the last 5 to 10 years that this has been a transformational technology. I'm not going to go into why. I could give a whole lecture on that. Another one is a wheelchair. So a wheelchair doesn't try to replace the legs of the person to have working legs, but gives them mobility to get around from point A to point B. And then there's mobilized wheelchairs and very fancy ones that climb stairs and so on and so forth. So amazing technology. So those are access technology. And I guess you could call them assistive technology too. But access technology doesn't have that ring of paternalism. Paternalism means that, well, think about disabled people are kind of childlike and that they need help, that somehow they're not capable. Access technology has the ring. They are capable, but just give them something that makes them even more capable. So now we'll move on to data. I just have one slide. 650 million people in the world are disabled, and I think that number is probably low. I have some reasons to explain that. 16% of the US population, ages 15 to 64, which is kind of working age, are disabled or is disabled. So and the 16% includes children who are learning disabled, for example. And 60%, approximately 60% of youth, school-age youth who are disabled are learning disabled. So it's a huge, huge portion there. Also, that 16% includes elderly, people that are losing their facilities. My father-in-law became blind at age 70, as an example, overnight. Very interesting case. 10% of the workforce is disabled. 5% of the STEM workforce is disabled. STEM stands for science, technology, engineering, and mathematics. That's us. Only 5% of us are disabled. And it's good to see that we have a couple of people in the group here who are disabled. So this university seems to be quite sensitive to that. So maybe the numbers are higher here. But only 1% of PhDs in STEM are disabled. So that's a huge lack there. We really need to have more persons with disabilities, simply to make our products better. So the impact of technology. This is one I'm pretty familiar with, personal texting by deaf people. So personal texting, I first became familiar with it in around 1970 when my parents got a TTY, which is in the picture on the left. It's a thing. It's about as big as like a washing machine and about as heavy. And the big innovation was the acoustic modem, because this teletype machine was personally for Western Union, and it sent electronic signals over a wire to another Western Union station. We don't call that personal texting. That would be, oh, I have to go into this place and give them a piece of paper with some text on it, and they will do the texting for me. That's not personal texting. But my parents had one of these in their house. And the modem, all it did was it translated the electronic signals typed on this machine to an acoustic signal, which could be sent over the phone line. So it's in the bandwidth that's acoustic. And then at the other end, there's a modem that transfers it back, and somebody with a similar device could start talking to each other by texting, and that was like a revolution. It really changed my parents' lives and changed all of deaf people's lives in the United States. And they become modern TTYs here in the middle. And you can see the acoustic modem there, and there's a phone on top. But you can plug your phone directly into these devices as well. And lo and behold, the whole world is doing personal texting with instant messaging. So it didn't start with Bill Gates or Steve Jobs or anybody in the hearing world. It started with deaf people because they needed texting to be able to communicate over a distance. There's a wonderful book by Harry Lang about the origins of the TTY. And I recommend that for anybody that's studying assistive technology. Optical character recognition for blind people. So optical character recognition, it started with Kurzweil, the Kurzweil machine, in the mid-1970s. Again, it's funny, it's about the same size as the TTY. It's about the size of a washing machine. And in this machine, you could put a piece of paper, a typed piece of paper, and put it in there, and it would read it and speak it out loud. So there was also speech synthesis, as well as optical character recognition. Now on the right is the KNFB Reader Mobile, which came out, I think, last year. Or maybe it was 2 years ago. And it's a handheld device which does the same thing as that other device. Furthermore, this handheld device is a standard, I think it's a Nokia. Yeah, it's a Nokia phone, and it's just programmed to be able to do optical character recognition and speak it out. So you can see there's been a big change. By the way, optical character recognition, you probably thought that was invented for something else, but it was invented for blind people to read. Okay. Speech recognition, hands-free access. So on the left is a picture of, actually, I think that might be Ray Kurzweil as a younger man. It was also the same guy, he's pretty influential. And the idea was to do a voice input to a computer to control it, or voice input to a dictation machine to write a letter if you're an executive or something like that. Well, that wasn't the original application. The original one was for people that couldn't type because they didn't have the use of their hands, they were quadriplegic or something else, so they could read in commands to a computer and have it do things. And my first demonstration of this was when one day I visited Boeing back in, I think, early 1980s. And they had a disabled person who was a quadriplegic, and he was a programmer, and he was working for Boeing. And he demonstrated this, first time I'd ever seen it, he demonstrated it for me. And it didn't work very well as he would like, and he was complaining about it a lot. But now they work really, really well. And machine learning and all sorts of cool stuff goes into these things. And on the right is a picture of a UW student, actually, who needs one of these, using it around 2006. And now, sort of as time has gone on, what's happened is that rather than have these sort of special devices like the TTY or the Kurzweil reader or whatever, these things become ubiquitous. OCR is ubiquitous. In fact, in the next 10 years, we'll probably have all the books that were ever written digitized, digital form, because of optical character recognition. And then of course, that'll be all searchable now too. So that people can do much more research and understand the past better. But the most recent trend here is that built-in accessibility. So if you buy Windows 7, you get with it a magnifier. So not only you can magnify something as you get older, you might want to do that, but anybody can magnify it that needs it. And it's already built in. And also Windows 7 has built-in speech recognition. He's like, not extra. No, it's not an add-on. It's already there. Now, it's not perfect. It's not as good as something commercial, but it's there. The iPhone voiceover. So there's a, I think you might have to add this app. I don't know how it works exactly. I haven't seen it yet. But with voiceover, your iPhone can speak to you rather than you read it. That might be very useful for a blind person. So these are built-in accessibilities into just everyday products. Now, some people would call this universal design. That when you design something, you'd like to design it for everybody regardless of disability. Well, of course, that's impossible. But you try to achieve that as much as possible. So there is this sort of aspect of universal design that's coming into sort of these ubiquitous computer products. And some of it's driven by legal mandate. There's Section 508, which mandates accessibility. It's kind of out of date now. It's actually been updated once before and needs to be updated again. But the federal government won't buy Microsoft products unless they're somewhat accessible. So there's this trend here. So this picture shows on the left, that we have these accessibility solutions. Clever people come up, like Kurzweil, come up with these solutions, and then they become mainstream solutions. They become part of the regular atmosphere, and we don't think back that where did they originate? Well, they originated because they were cool problems to solve for some interesting people. So I'm going to talk about a new trend, a potential trend. So on the left, I talk about standard programmable platforms, which are popping up everywhere. In fact, the iPhone is an example of such a platform. 15 years ago, maybe 10 years ago, there were no laptops. We all had computers in our houses or in our workplaces, but we wouldn't carry them around. And now, these are computers. These cell phones. So what's happening is these standard programmable platforms can become multifunction accessibility solutions on standard platforms. So rather than have special purpose devices, you have this general purpose device that you can just program up to do different accessibility solutions. So I think that's the trend of the future. And that kind of makes it exciting for computer scientists because you don't have to build hardware. You just do software. So I want to talk about a little experience I had with the digital pen. And I think Matt will like this because I have a picture of a finite state diagram from Sipser's book. So I'll give a little background here. So this is a tactile graphic. And I can't, show a picture of a tactile graphic. You'd have to feel it. And so what's black is actually embossed. It's up, it's higher. So you can feel what's black. And then the white's background is just not embossed. It's down low. So a blind person can feel this and see that there are these three circles and that there's arrows between them and the transitions between the states. There's only 3 states here. And in a normal tactile graphic, you would have to put Braille printing in there just to describe. You can't have a graphic without text. They just don't work for anybody, much less blind people. So there would be some text in there. Well, this is what we decided to try, and it wasn't my idea. It was a guy named Steve Landau, who works at Touch Graphics, told me about this. So there are these digital pens around. So digital pen, and this tactile graphics have been around a while. And this digital pens is new technology. So digital pen, if you have this special paper, which has little dots on it, the dots actually are a signal. And when you put the digital pen, there's a little camera in the digital pen that'll pick up that signal with a infrared camera, and it'll translate that into a location on the paper. And if it's programmed inside the pen, what that location has any text in it, or it has a voice file associated with it, then it'll speak that voice, say what's under the pen. So my student, Josh Scotland, and I said, well, let's try to do tactile graphics with a digital pen, because then we wouldn't have to spend all that space on the Braille. And by the way, a lot of blind people don't know Braille. It's unfortunate if they don't. So this might be a nice transition to Braille. So we got the digital pen, and we couldn't do a thing with it because it was kind of a turnkey system. In other words, it was not programmable. There was no SDK for the pen. And and Josh would go to the kind of the I don't know what you call it, the web page where people discuss digital pens. And this company had such a page, and everybody wanted an SDK. They want to be able to program it up because they want to do their application, whatever it is. And so now there is an SDK for the digital pen. So you can write a program that will do, not everything, but it'll do some things that you want. In fact, it can do this. So I didn't bring the example with me. I should have. I just didn't think of it. So you can't see it very well, but it looks a little bit grayer inside those little tiny small circles. And so in there are those signals that the digital pen can pick up. And so if you touch one of those, for example, if you touch the circle in the top circle, it'll say Q sub 0, which is the start state, so to speak. And then, the Q sub 1 and Q sub 2 and stuff like that. And those circles over there are rather long pieces of very abstract text. So this is a particular finite state machine. It's not like a single letter or something like that. So the point is that if you have a programmable, don't think of programmable devices as just computers, laptops, cell phones. It's like almost anything that's coming out now is a computer, and you can program it up. The program development environment is just, Windows-style program development environment, and you can do lots of stuff. So now this ubiquitous device becomes an accessibility device suddenly. I didn't have to build any hardware, but I did need the software. I need access to the program. So this is kind of the new trend I'm trying to tell you about. Okay, what's the problem? So this article from just last week, New York Times, with the title, it hit the local paper here too. Glad you still have one. So the title of this article was "Insurers Fight Speech Impairment Remedy." So I didn't want to. There was too much to put in this, but the gist of the article is that insurers, including Medicare, not just these private insurers, won't pay $300 for a speech solution on an iPhone, but will pay $8,000 for a single-function medical device in quotes, for text-to-speech generation. There's something wrong with that picture. That's like, huh? But this is it. That's the medical model. The medical model is you're sick, you need some special device, and by the way, it's going to cost you a lot of money. You see the problem with our medical system? It's just like crazy. And I think part of it is disabled people they're not a medical problem. Unfortunately, I don't know if insurance should have to pay for anything if it goes for a disabled person. Maybe they should be paying the small amount. I mean, we should be building devices for them that are really cheap. They're just programmed up, and they're off and running. So I write why. Well, the iPhone is not considered to be a medical device. So they won't pay for it. Because it's this general purpose device. By the way, we have computers, It's like disabled people viewed only in the medical model. So that's the problem. Yes. No, I haven't heard. Okay, so I should probably repeat that for the other audience. So the gentleman in the audience said that the company that manufactures this $8,000 single-function device, it really is a personal computer, but it only can do that one function. It's locked. And so for $500 more, you can get $50 more, you can get it unlocked. So that's kind of interesting, but you got to get the thing first. Yeah, well, you can see, if this thing is broken in our medical system, most everything is broken. Yeah. I think, well, I don't want to get into it. But should I repeat what you said? Because the other audience. Right. So the previous. Right. So this was also done in the past, as repeated, for lots of, in quotes, medical devices. So this is kind of my vision, for the future. A blind person buys a standard cell phone or with a data service. They're just like you and me. And then for accessibility, they just download applications that suits their needs. GPS application for location and directions, barcode reader so they can see what they're buying at the store, OCR application, and so on and so forth. So this is kind of a move from the medical model to the social model. You see? We're not thinking of this as a special purpose device. We're thinking of it as a general purpose device that can be, changed by a program to something that's useful. Now let's get to accessibility research. So I want to talk a little bit about kind of the trend here. So CHI, C-H-I, is the leading human-computer interaction conference in the world. And I did a search on the word disability over the last umpteen years, approximately 30 years, in years of 5. So from 1982 to 1985, there were no papers that had the word disability in it in CHI. Nobody was interested. Between 1986 and 1990, there were 5 papers, or 2% of papers. Between 1990 and 95, there were 15 papers, which is about to 5%. And then between 1996 and 2000, there were 19 papers, or 6%. So you can see why I was not able to get funding in the 1980s for my work. So nobody was interested. And I have too many stories to tell from that era. Ask me later. So between 2001 and 2005, there was some transformation, some change. Suddenly people got interested. There were 88 papers that had the word disability. I looked over those papers and they really have something to do with disability. Things from brain interfaces to all sorts of things that I can't even imagine ever really happening. It's all cool research. I'm sure not even 1% of it became products, but very interesting anyway. And then between 2006 and 2009, which is this year, there were 158 papers in the last 4 years, which is about 20%. So there was a change between the end of the 2000s and 2001, and maybe the only thing I think that coincides with that is 9/11. So I don't know, maybe people started thinking more about other people or something like that. So the point I'm trying to make here is that it really is a hot area. It's something to think about. And every person I've talked to today had an interest in it, from people doing software engineering to people doing other things as well. There's other conferences, the Assets Conference, which is coming up this next month, ICCHP, which is sort of a European research conference. HP used to stand for handicapped people. It's now called helping people, so got rid of that word. The CSUN conference is the biggest one. It's more of a technology conference, not so much research conference. ATIA, it's the Assistive Technology Industry Association conference is another one. And W4A is basically web accessibility. So now I wanted to talk a little bit about the actual research that's been going on at the University of Washington. I can't do all of it, but I'll give you a little taste here and there. You actually saw the digital pen work earlier. So Web Anywhere, and for all these projects, there's some name and then the tagline. So this one is a screen reader as a web application. And I hope it works because I'm going to try to demonstrate it. And it's won a bunch of awards, mostly because of Jeff Bigham, who was a student at the University of Washington, is now a professor at University of Rochester. So in this picture here, a picture of a screen reader, and it's just a web page. And at the top of the web page is your regular browser header. And if you type in the address to Web Anywhere, you get the Web Anywhere frame, which is the top here, next to the top. And then you get any other web page down below. Whatever that web page is down below, you can read it. And the navigation is simply by hitting different keys, like Control-L will take you to the place where you can add a new URL to go to a new web page. Control-I takes you to the next block where they need input. I is for input, so the next input block. And it'll read it out for you if it's accessible, what it's supposed to be in that. The down key takes you to the next link. Control-H takes you to the next header. So it's very much like what's called the JAWS screen reader. It's a little bit slicker in some ways. It's not a full-blown screen reader, though. It's only for the web. So let's see if I can demo this. It won't be a very long demo.
Web Anywhere has loaded. 3 headings 1 blank. Welcome to Web Anywhere. Heading 1. Web Anywhere. Location field text area. //webanywhere.cs.washington.edu/data. Location field text area.
This is the beta version. I'm typing into Google. I thought this was. Oh, .com.
I could imagine it being Google.edu.
I typed in Control-I to go to the Google place where I can enter data, and then I'll type in, I don't know. Let's see. Any Anton.
Page has loaded. Web 75.
Go to the headings.
Head 2. Search. Head 3. Link Annie Anton.
Okay, and then I got to Annie Anton's webpage. And actually what I was looking for was her phone number so I could call her up. So it stopped reading for some reason. I think I hit the control character by mistake. Anyway, that gives you an idea how this works. So it's all inside of a browser. So let's go back to the talk. I should have done the alpha version instead of the beta version. So I wanted to talk about mobile accessibility. It was very closely related to that scenario I gave you earlier. And this is a new project that's not even on my webpage. It's a bridge to the world for blind, low vision, and deafblind people. So basically it's using like a Google phone here as a base to build accessible applications like the ones I mentioned, a barcode reader, and we've already done that. There's a barcode reader on this phone, and so on. So the idea here is a little more broader than I said earlier. So I have this phone. It not only has some capabilities itself, like the KNFB reader, so that you can do things on board, but it's also networked. You know, it has the T-Mobile service. And so, for example, to do the barcode, I can read the barcode, and I can just go look it up on the web what it is. You know, all done automatically. Or you can go buy a single-purpose barcode reader as a medical device that costs $1,000, and the database is on the device itself, and it's just not up to date. So, you know, there's your choice. Download a little program, or buy some special-purpose device. This has GPS. It has an accelerometer. It has a compass. It basically has a lot of senses. So why not translate these senses with services so that you can use them if you're a blind person or a deafblind person? Also, you can think about not just the services being sort of automatic services like web searches to find barcodes, what they mean, but also human services like Mechanical Turk. So you could perhaps take a picture of something, you have no idea what it is, you know it's important, like is that the men's room or the woman's room, you know? And you can take a picture of the door and send that to Mechanical Turk, and the guy will, or the gal will type back, or maybe call you on the phone or whatever to tell you, oh, that's the men's room. So you have this extra sensory device, and you can have human services or automatic services, all on this one device. So that's sort of our goal. And of course, we've written proposals to do that, and they're not totally funded yet, but we're working on it. I wanted to talk about one special feature that we programmed in this phone. I call it vibrating braille, or V-Braille. So making braille accessible using a touchscreen and vibrator. So I actually have try to running on this? Yeah. I don't know if you can hear this. So there's a blind person here, right? So I'm going to go through this, the Braille cells. This is 1 is on, 2 is not on, 3 is on, 4 is not on, 5 is on, and 6 is on. What letter is that? 1, 3, 5, and 6. Z.
Letter was Z.
There you go. So I'm going to hand this to this gentleman here so he can try it out.
Can you hear me, Richard?
Now, if you get to the next letter, you want to go to the menu key, which is at the very bottom of the screen. It's a little tiny key. Is there a question? Yeah. State your question.
Wouldn't Morse code be radically better than that?
Yeah, we program Morse code, but when I talked to all the deafblind people I know, nobody knew it. But they did know Braille. So they can have Morse code too because we program that in also. And I don't know if the Morse code app is on there right now, but so we thought that in the past I did know some deafblind people who did know Morse code, but apparently that it isn't learned anymore. Thank you for your
Yeah, it gets ignored because it's old, but it's so much better than 6 impulses per letter. It's just unbelievable that we would persist.
Well, I'll have to convince some of my deafblind friends to go to Morse code and tell them about that. Because we have Morse code on the phone and we could teach them that and see if they like it. So somebody in the audience said that we used Morse code in the past for computer access. But that was in the 80s. So, well, anyway. So the picture on this thing shows that device. Did you find the menu button there? Okay. So I don't want to distract you too much from my talk, though. So I think what's kind of interesting about this is that this Will Johnson, who, I didn't invent this Braille myself. Will Johnson, who just happened to meet, he never met a blind person in his life before I introduced him to a blind person. He never met a deaf-blind person, ever, until I introduced him to a deaf-blind person. Within a few weeks, he came up with this idea. And of course, I didn't know if it would work. So we brought it down to a deafblind retreat where there were about 70 deafblind people, and showed it to the people. And the first person read it. The very first letter they read, they understood it and told me what it was. It's like, how many nice experiences do you have where somebody actually finds something usable from the very first moment they tried? Now, nobody's perfect, and she didn't get the next 2 or 3, but she did get the first one. So it was kind of exciting. So every deafblind person that we use, we tried it on, they were able to use it. We also tried it on some blind people. So I want to talk a little bit about MobileASL. It's a mobile video phone for sign language users. And I actually have one here, and I'd probably, if I had time, I would make a phone call back to Seattle and try this out. And this one here, I have it set up so it just works on the wireless in the building. And so you can use it on wireless. It also can be used in some cases with like an AT&T data service. There's kind of a buzzing noise. I don't know what that's going to be. Is there somebody touching something over there? It sounds like somebody's taking a shower here. Okay, I'll keep talking. So I thought I'd just show one video, and this is one where the sound has to be higher, because this is another YouTube video. Stop and tell. I'm gonna get it larger. So this has captions on it. So
MobileASL is a video compression project with the goal of enabling real-time sign language communication over the standard wireless cell phone network in the United States. Due to the low bandwidth of the standard GPRS cell phone in the U.S., today's cell phones cannot use the quality for intelligence. To existing net sign language. With the H.264 compression standard, the perceptual processes that occur in conversations in sign language, but specific to the definition to the freedom and important.
Question from the audience, yes. Yeah, so the question is, can this be integrated with web conferencing tools? Right now, it's just point-to-point. So it's more like a point-to-point phone call, like a video phone call. We're putting in some protocols that would be able to be compatible with video conferencing, but unfortunately, video conferencing uses very high bandwidth, and we're using very low bandwidth. So the compatibility is somewhat limited. If they pump out a lot of data to this phone, it's just not going to work. Okay, this is just for a sign language phone call. It's not for like educational purposes. So the intention is not to have everything captioned in this case. It's like, oh, there you go. Okay. So another piece is ClassInFocus, which is making education more accessible for deaf students. So the idea here is this is a screen for a deaf student in, let's say, a classroom, or maybe for all students in the classroom. And on the screen is the picture of the lecture, a sign language interpreter, the PowerPoint slides, and perhaps some captions from real-time captioner. Now this sign language interpreter might be at a completely different site. It doesn't have to be at the same place. And this captioner can be a different site, just with headphones on listening. Sign language interpreter, of course, would have to have some sound coming in so it could hear it. So these things are all connected by some modern teleconferencing product like Adobe Connect. And Adobe Connect is another product that has an SDK. Isn't that cool? So we can program this thing up to do what we want. For example, we can make these boxes any size we want. We can minimize things. We can move these boxes around. We can change the color for somebody that's colorblind or wants a different color on the text, things like that. So it's very individually programmable, and it can be done differently at every site. So most Adobe Connect products, the turnkey products, don't even allow any of those functions. Okay, and this is a joint project with RIT, where I'm actually going up there tomorrow, Rochester Institute of Technology, and so we're working on this together. I don't have a video or anything for that. The next one is ASL STEM Forum, which is enabling sign language to grow in science. And this project here was motivated by the same educational issues that deaf students, when they go into a classroom and it's interpreted, it's a science classroom, but the signs that they're using might just be kind of local to that classroom between the two people. Sign language isn't around that much. And I think I want to go directly to this website. So this is the ASL STEM Forum website. Why is it sort of embedded in this other thing? Anyway, so it has different categories over here. This one? Oh, yeah, it's way over there. I don't know why it's way over there. So we can do a search, for example, on the word array, which is a computer term. So array, here's the sign that this gentleman uses for array. And of course, you can make this larger if you like. So he's spelling the word array first, and then he's giving the sign, which is like, oh, it's a loop, excuse me, it's a loop array. Oh, an array loop is what he was defining there, not an array. So my mistake. We go back over here, it's just the array itself. Now I know this is not the sign used in Texas, because I saw somebody do the sign in Texas. So, you know, and the sign in some other city is done differently and so on. So that's the one, he's a Google employee. And so he and his interpreter have worked out that sign for array. I was going to look up one other word, algorithm. Did I spell it right? So here, there's this sign, but there's also these alternative signs down here. In fact, I put one in myself one day. But so there's ways to put in alternative signs, and then you can do discussion about those signs below. So this is a fairly new project. We sort of put this together about a year ago, and let me go back to the slides. Gosh, why does it do that? Okay, there we are. And we're working with Gallaudet University, and hopefully I'm going to try to convince some people at National Technical Institute for the Deaf to do this. So Caroline Solomon, or Carrie Solomon as I know her, is going to do biology, physics, and chemistry. At least she's going to have her students do it. And so these will be the signs from Gallaudet, which probably should be in there, because that's a major university for the deaf in the world. I always like to give an open problem. I'm kind of running out of time, so you guys know what CAPTCHAs are? Everybody know what a CAPTCHA? Anybody not know? So CAPTCHA is a way to prove you're a human being before you go into something, so that bots can't go in into the same, like create a whole bunch of Gmail accounts. So the first one here is a visual CAPTCHA. The second one here is an audio CAPTCHA, and the sound should be lower. If you didn't lower it, this might be too big. Remember that? Anyway, you can imagine kind of typing it in quickly, but unfortunately the systems that are out there don't allow you to type at the same time you listen. Well, the real problem here, and so an audio CAPTCHA would, if they worked well, would be good for blind people. Certainly the visual CAPTCHA is good for sighted people to prove you're a human. But what about somebody who's deafblind? They can't use either of these. So what about a text CAPTCHA? And I have a kind of example of one here that in quotes it says, what is the sum of 2 and 4? You would think only a human being can answer 6, you know, that somehow a machine can't. But of course, machines are smart. They can, anybody in natural language here? I mean, you know, this is probably a pretty easy natural language problem. Yeah, right. So maybe I can distort this and type, instead of what, I'd type where. You know, or something, you know, confuse it, you know, try to confuse the natural language processor. But to tell you the truth, nobody knows how to do a text CAPTCHA. And by the way, a text CAPTCHA would be good for everybody, not just deafblind people. So, you know, you young Turks out there, you hotshots, solve that problem. By the way, you'd be very famous. The guy that invented CAPTCHAs, his name is Louis von Ahn, is quite famous. So do a text CAPTCHA, and you'll actually solve a big problem called the Turing test. So a little bit about empowerment. I have to be pretty quick. So we know about these HCI concepts. User-centered design, involve the user at every step, and here's a little diagram over here. Universal design, design for all users if possible. Little picture here. So the new concept is design for user empowerment, designed to enable people to solve their own accessibility problems. So you want to build things that is not just an assistive technology device, but something where people can, you know, do stuff with it. They can download it, they can do whatever they want, and they have more accessibility than they had in the past. So an example would be a cell phone becomes an accessibility tool. Users download accessibility applications. That's sort of a theme throughout. Social accessibility. Users interact to accomplish an accessibility goal. So that would be like, for example, the ASL STEM forum. So the users of ASL are cooperating to actually improve accessibility to education. Finally, sort of the highest level here is persons with disabilities with superior education can solve their own accessibility problems. So give me a chance to talk about Nicole Torcolini, who was somebody from the Seattle area. And I found out some people here know her. Well, years ago, when she was in high school, she actually took quite a bit of computer science, AP Computer Science 1 and 2, and was quite a good programmer in high school. When she took math, she wrote her solutions out in the Namath code, but her teachers didn't know how to read Namath code, and so somebody who did would have to translate her solutions to math so that her math teachers could understand her solutions. And so she learned about LaTeX from actually Se-Young Han, who I told you about earlier, one of my students. And she realized immediately that she could probably translate Namath to LaTeX. And then LaTeX can be compiled and printed to have the most beautiful math in the class. And she did that. So she invented a translator that takes Namath code and produces LaTeX, and then she just runs it through a LaTeX compiler, and it becomes printed out and becomes beautiful math, and she had the best math in the class. So the power that she learned how to program so she could solve her own accessibility problems and also accessibility problems for everybody else. So the key is, that we don't just provide assistance. It's like, remember the story about, you can give somebody a fish or you can teach them to fish so they get their own fish. Well, that's what we need to do. So that's sort of the highest level of enabling, is letting them do their own solutions. And not every person with a disability will want to do that. Gerard Vermeij, that famous evolutionary biologist, has no interest in building accessibility applications. He's a biologist anyway, he's like soft, gooey stuff. So, but some of them will, and so we should do that. So that leads me to this final thing, this access computing project. I think, can I run over like 1 or 2 minutes? So the goal is increase the participation and success of individuals with disabilities in computing careers. And we work with a bunch of different organizations, a national program. And I'd like some stuff to be done here at this university with this. We're doing different activities for students directly. That's objective 1. I'm not going to read this to you. And I wanted to highlight internships. So we fund internships, especially research internships for students with disabilities who want to work with faculty members on research. So if you have a student or you know about a student that you don't have funding for, we can provide that funding. We also work with departments to make them more accessible, but we're not evil. We're not going to try and push you too far. We want you to be friendly with us. And we also have these capacity building institutes, and actually you could have one of these we could fund it. Capacity building institutes here to help the department. And other departments, you have the research triangle, maybe all of you should be working on this. Create a nationwide research, so we have a knowledge base, so you can go there and get your questions answered. And if you have an answer to a question, you can contribute to the knowledge base as well. So those are and I have some brochures here you're welcome to take with you when you leave. Unfortunately, I can't transmit them to you at the other sites, but just send me email and I'll make sure you get one of those brochures. And there's our web page, and most of what I'm telling you is about access computing is on this web page. So it's a very important project. It's National Science Foundation funded. And it's about $1 million a year, and getting as many universities involved as possible is one of our goals. So I want to thank you all for listening, and hopefully I didn't run over my time too badly.
So let me take questions from the remote sites first. Any questions from Duke or UNC?
One guy just stood up and left.
Can you guys see us?
Yes.
Yes.
I have a question.
Fire away.
These days there are laptops and tablets coming out with touch screens. Do you think there is something already out there, or any project which is trying to like make use of these touch screens to make computing more accessible for blind people, or do you think there will be any such trend sooner or later?
Do you mean a standard touchscreen or some novel touchscreen that actually has new technology that allows it to sort of change its shape? For example,
It's basically multi-touch, but on laptops. Like you showed an example of a mobile device where it can vibrate, but I would guess that would be slightly more difficult with laptop devices. I'm not too sure, but
I think the answer is I don't know of anything like that. But if you're talking about a deafblind person, there are devices that you can attach to a computer which will output Braille, so you get at least all the text. Now that special device costs multiple thousands of dollars, but at least you have accessibility through Braille.
okay.
If it's and they might be able to use the touchscreen. I don't know of any applications that do, but you might be able to.
Okay. Thank you.
We're just talking about laptops. Yes. He was actually specific about laptops. He was specific about laptops and not iPhones. iPhone is not a laptop. But
Yeah. Thanks.
Anybody else out there? Okay, let's some local questions.
I was wondering if you had anything to say about social or intellectual disabilities.
oh yeah, that's a good question. Social or intellectual disabilities. I have to admit that I am, I'd hate to say, a little bit partial to deaf and blind because I'm most familiar with those. And although I do know some people with Asperger's or have children with Asperger's and other debilitating syndromes like that. So I don't have much to say myself, but I think a lot of the things that we're doing could apply not only to that group, but people who are losing their ability because of age, like with Alzheimer's and so on. So things that can substitute for memory can help somebody remember. In fact, I have a close friend who had encephalitis and lost his short-term memory. And so he can't remember if he eats breakfast 5 minutes later that he ate breakfast. And so he could use some kind of device, somewhat similar, handheld device that help him take care of, remembering that he ate breakfast and things like that. Maybe a checklist or whatever. And I believe there are people doing that. I'm just not very familiar with it.
I have to be loud. Okay.
Yeah. There's nobody there.
Yeah. I made a quick observation when you were presenting your web page, the Web Anywhere, was it?
Yeah.
Right. Is there a need for emergence of maybe standards? Because all the applications seems to feed off of HTML, where if you have a image that talks about that probably shows mountains, the reader would not be able to read it aloud because for the simple fact that it's an image. So would you need, is there a need for emergence of probably better standards that would encode that information as well?
There are. There's the WCAG standards. Yeah, there's a ton of standards. In fact, there's a new one that just came out this year, WCAG 2, so WCAG. So look, that's a web accessibility, did I say that right? Web content accessibility guidelines. So it's a tremendous amount of information there about.
So and then I presume that you would have guidelines as well for developers who develop websites and to be aware of.
Are you talking about the website developing tools? Do they have?
Not tools as much. Maybe the developers. How do you guide developers to develop?
Yeah, there are books on that.
Right.
Yeah, there's a number of books on that and web pages you can go to for web developers.
Also, the W3C has, in addition to the Web Content Accessibility Guidelines itself, there are supporting documents like HTML techniques or XML techniques. But I think more importantly, there's an emerging standard called ARIA, which stands for Accessible Rich Internet Applications. And that standard, which also has, it's got a best practices guide and a piece written for an implementer's guide. And it basically takes an object-oriented approach to rich applications on the net.
I was going to say just one high-level word about this is, even though there are standards, they're all voluntary. And the number of contributors of web content of one kind or another is in the billions of people. And there's no way to enforce these things. So I think another approach is to take whatever is out there and try to interpret it correctly or transform it to something that's more accessible. And we have this project called Web Insight. I didn't talk about it, which that's the goal, is to take inaccessible web pages and make them more accessible. Because you're not going to be able to control everybody out there, even though there are these standards.
I'll just say from observation at our campus, where we have a web accessibility standard, the social conflict of trying to keep everybody, including the uncontrollable faculty, in line has been significant. And so I think your point about the voluntariness of it, on this campus it's not voluntary, but it's not easy to get everyone to comply.
I heard one story today from a faculty member where somebody said that they couldn't put up their papers that were LaTeX, LaTeX papers. And
they were
math
they were early PDFs.
Early PDFs.
Early PDFs before that became. Yeah, but this has been a bone of contention.
Yeah. Yes. Behind you. Yes, go ahead. Oh, let her go? Okay. Ladies first.
So my whole goal, when you all are doing research, it's easier to find one way of people can author, just get over all of this, so that the workflow they can get into that automatically does these translations for them. And there should be a tool that will allow this to automatically go through the process. You have it, you submit it, it goes through, comes out the other side. If you have these workflows that smooths out this process, we've got all these discrete things that happen, then I think you will have more compliance. Because everybody does their own thing that they know best, put it through this and it comes out on the other side for whoever it is. That's what's needed.
Yeah, I think that would help a lot, but it's still going to be a losing battle. Can't make people do things.
I'll just hold it. Yeah.
Gotcha. So you had mentioned the difficulty in finding research dollars in the 80s.
Yes.
What's the difficulty now, and what are the sources of funding?
Oh, sure. Yeah. For the research, there's National Science Foundation. For the access computing, I talked about at the end. That's a sort of a people-oriented. There's a program called Broadening Participation in Computing, which is trying to get persons with disabilities, minorities, and women into computing. So that's for a people-oriented or human resource-oriented project. For the research itself, within NSF, you can talk to me later, but within NSF there's a lot of possibilities. There's also the Department of Education, the NIDER program there. I've never been successful getting any money out of them. Comment privately about that. There's also industry, like Google is supporting some of my work because they're interested in Yahoo and they're kind of interested. Yahoo's not supporting our work, but I think those companies are very interested, especially with the web accessibility.